Hi, everybody. We're going to do match quadratic functions and graphs, which is the IXL BB.14. Let's take a look and see how they do this. I assume they're going to give us a graph and an equation. Oh, okay, so we have to match them up. Let's take a look and see. Oh, we've only got two to choose from. So first of all, we know that this one goes through 0, 6. And we can see that 0, 6 is the y-intercept. And we can see this one is going down. And of course, because it has a negative coefficient, that's enough to be able to match them up. Well, we won't do any more than just match them, just enough to get the right answer. So let's see about this one. Now this one, we have a positive graph and a negative graph. Okay, guys, as you can see, this one, let me see, I can maybe draw a little. This one over here on the right has a negative as its leading coefficient. So that means that it's going to go down. Whenever you have a -1 for your a value, for your ax squared, if that value is -1, then it's going to go down. And in this one over here, on the one on the left, we have an x squared minus 2x plus 2. There is a 1 in front of it, so it is a positive parabola. So anyway, that's all you needed to know for those two. Let's see about this one. Now this one, oh, okay. In this one, we know it goes through -3 and -4, and that's the zeros for this one. And so they're giving you some extra information, not that we really needed it. Here's the x squared plus 4. We can see it's x squared plus 4 here. Clearly, that is 0, 4 is your y-intercept. This one has a y-intercept of 12. We can't quite see it, but it's there. So there it is. And all right, I'm just going to leave my eraser on for now so I don't mess it up. All right, so we've got an x squared plus 5, and here it is. Take a look. It goes through, I can draw in this now. There's my 0, 5. That's my y-intercept, and it's just a translated 5 up. This one right here, let me put it over here. Oh man, look what I did. There we go. Clearly, this one has been moved, excuse me. It has 2 zeros. It looks like 8 and 7 are the 2 zeros. And there it is. The vertex is between 7 and 8. And there's the zeros that you can see up here. That gives you a 0 of 7. That's why this has a 7 on it. And this one has a 0 of 8, which is why that point is there. So hopefully that's clear. Now let's take a look at this one here. Now this one, this thing has been translated 5 to the left, which put it 5 to the right, sorry, right here. And there it is. And we're going to put this perfect square trinomial over there. Darn it. There we go. Using my finger, that's what I get. This one is extra steep because it's got a 2 in front of the x squared. And they also told us, based on this, that -8 is my 0. Remember, whenever you 0 the square part, that's where your vertex is. So that's why the -8 is my vertex. -8 does give me 0 when it's squared. So there it is. So I'm going to move it over there for you. Okay. All right, now this one, a couple of things are happening. First of all, it's going to go down. Second of all, it's going to have a vertex at -7. Well, clearly it's this one over here on the right. This one is down and steeper and going through 0, 0. And clearly it's the one on the left. So this one, let me use my eraser, there we go. This one is extra steep and it goes through 0, 0. This one, they gave you the factors, and let me move it up just a little bit. Those factors tell you that -7 will give you the 0 for the squared term, which is where your vertex is located. Let's see, what do we have here? We have an x squared plus 3, which is a moving it up 3, so clearly it's the one on the left. And the other one is x plus 6 and x plus 2, and those really are my zeros. When x is -6 and when x is -2, those are right here. There they are. See them? And this one right here, when x is 0, we get 3, which is right there. And that is my vertex. Notice that the 0 is being squared. Anyway, a lot of things going on there, but let's go ahead and put them in. This one goes here, and this one goes here, and we're done. All right, I don't want to spend too much time. So same idea. They're both going down. Clearly, this one is right here, and this one is right here. All right, one of them's going down and one of them's going up. That's all you need to know. Here's my +1, and here's my -1. I'd like to do more analysis, but I know you guys like to just kind of move along and just get enough information to answer the question, which is fine too. All right, no need to analyze this one a lot. Notice that we're going to have zeros at -9 and at -6, and here they are, 1, 2. So there it is. Obviously, the other one is 0, 0, and it's a little bit extra steep. So there they are. Just do that, and we're done. All right, let's see what we got here. Okay, so we have a -x² - 1, which is right there on the right. And this one over here has a 0 at +2 for the x. See it right there? That's where that vertex is. And notice it is going up, and it's extra steep because it's got the 2 and as its leading coefficient. This one has the -1 as its leading coefficient. So there we go. I like these. These are fun. Oh, more of them. This is going to be much more fun. Okay, so look, this one, 8 is our special point, and 8 gives us 0, and that happens to be our vertex. So 8, 0 is our vertex for this one. This one, 0, 0 is our vertex, and it's going down. This one, 0, 2 is our vertex, and it's going up, and it's steep. And this one has zeros at -8. We write the point like that, -5. We call these roots or zeros, and they're on the x-axis. So lots of stuff going on. Let's go ahead and take a look at them all. So this first one here is our -x². Oh, let me get rid of that real quick here. And there we go. And now we have this one is going to go at -8 and -5. That's this guy right here, and it's extra steep. This one is the one that has the 8 as its 8, 0 as its vertex, and that's going to be this guy right here. Oh, the wrong place. There it is. And this one is my 2x² + 2. There it is. I can see it. I just got to get, no, it's down there. There we go. And there it is. So just a couple of things I want to mention here. First of all, this one is clearly 0, 2 is the vertex. And this one, -80 is the vertex, and it's going down steeply. And we can see that it's heading in that direction. This one, well, that's enough. That's enough analysis for this. Clearly they're right. All right, let's see if I can do the minimum this time without going crazy. Okay, so this one, we're looking, let me put, oh, there, that'll help. So the f of x has negative 5, 0 as its vertex. The g of x, move it up just a little bit, g of x has a vertex at 0, 1, and it's going up. It's a standard parabola. H of x has a vertex at 0, negative 4. See, take a look. And it's going down. And k of x has 2 zeros. One of them is 0, 0, and one of them is 4, 0. Those are your called your roots, or where they go through the x-axis, and here they are right there. And that is my k of x, isn't it? And of course it is going down. K of x is going down because that is a negative coefficient in front of the x squared right there. So lots of stuff going on. Let's see if I can help it out here a little bit. Okay, so this one right here is the negative 5, 0. So this is the f of x. Oops. Let's see. This one is my 0, 0, my 4, 0. So this is my k of x, which is right here. And then we've got, oh, it's hard to mess with these. Does it let me? It doesn't let me put it over there. Let's see. It's hard to work with this. Okay, so the negative x squared minus 4. Let's just stick it in right there for now, and then we'll fix it in a minute if we need to. Oh, come on. Get up. Don't want to hit the submit by accident. Okay, so these are backwards. Wow, that's really hard to. Okay, there we go. So let's make sure. Yeah, 0, 1. This one does have a vertex at 0, 1, and it is going up, and the one on the left there is going down. So there it is. There's got to be a better way to do this. Probably works better on a bigger screen or something. All right. F of x, we're looking for, let's see, I'll just write it down here. F of x, we're looking for the vertex at 2, 0. When I put a 2 for x, it gives me that 0 squared, and that's going to be where my vertex is. My vertex for this one is going to be where the 0 is squared, and that gives me 2. So 0, 2 is g of x. And then this one is going to be at 5, 0, but it's going to go down. So h of x is going down. Both of these are going up, by the way. H of x is going down, and my vertex is going to be at 5, 0. And this one is going down, and I have what we call roots or solutions or zeros at 4, 0, and 5, 0. By the way, your vertex is right in between those two. So your vertex is going to be a 4.5, and it's going to go down. So anyway, a lot of stuff going on there. Let's see if I can match them up here real quick. This one is the x squared plus 2. This one is that f of x, the 2, 0. There it is. And then our other two, looks like 4 and 5 are the ones on the left. So this one is my 4 and 5, which is the one on the left over here. Man. Oh. I'm really making a mess of this, aren't I? Okay, and then this one is 5, 0. Oh, no, 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 no. This one goes over here probably. Yep, 5, 0, there it is. I really made a mess of it. Come on. There we go. Looks like I finally got him in place. Let's get rid of this real quick here. Oh, man. can't look at the whole thing at once. That makes it really difficult. Okay, so yeah, it looks right. I don't like it. I wish there was a way to look at them more carefully. Oh well, you know what? I'm not going to write anything. I'm just gonna drop them down here. This one is going through 0, 3, so there's my vertex. And this one is going through 0, -2, so it's got to be this one right there. And then this one is the steeper of the two, so it's got to be on the left. And this one is not as steep, so it's the one on the right. That's basically all you need to know to be able to identify them anyway. You can look at the steepness. Okay, so let's see about this one. Now on this one, it's at 4 and 6, so it has to be this one right here, which is x minus 4 times x minus 6. This one has zeros at -3 and -7, which is this one right here, because x plus 3 times x plus 7 gives you this trinomial. The x squared plus x, and the other one is down. So obviously this is the one that's going up, and this is the one that's going down over here. And we can see that this one's going down, and I'll write it in there. There's your 0, -5. And for this one goes through 0, 0, which is something we would expect. That's your y-intercept. And the -1 is your other 0. And then right in between those is your vertex at -1/2. So lots of stuff going on there. Kind of fun. Let's see. It's better if I don't try and write on them. Okay, so let's see if we can just identify some of the stuff here. Let's see, I started writing on it, unfortunately. Okay, so this guy is going to go up and it's going to be steep. It's neither one of these. Both of these are down. So one of them is this one right here with the -x squared. Now this one has an 8 at the end. So -2 and -4 are my zeros. This one has zeros at 3 and 4, which means that 12 is the only possibility. And of course, they're both going down. Now, both of these are steep and positive. One of them has a 0 at 18, and the other one has a 0 at 72. So clearly, the one that has a 0 at 18 is the one on the left here. So this one has to be the one on the left, and this one has to be the one on the right. The way I can be certain is this positive 72 is my y-intercept, and the 18 is my y-intercept. We can see, based on just looking at this part right there, that that's going to cross the y-axis pretty soon at 0, 18. This one is going to take much, much longer, and it's going to arrive at 72. Of course, we also can look at these zeros, and we know that this one is x minus something, and this one over here on the right is x plus something. So a lot of ways to tell which one's which. All right, let's see here. What do we got? All right, we have a positive and a negative. The only negative one is this one, so there it is. This real quick here. There we go. This one is through -4 and -5, which is this one right here, x minus 4 times x minus 5. And then we've got two choices. We've got 2 and we've got a 1. The steeper one is on the left, so it's this one with the 2 is the coefficient. And this one on the right is a little bit less steep. There's a couple of other ways we can tell. Of course, we can see it's going through 0, -8, and there's the -8. And this one over here has zeros here, here at 9 and 5, which gave us the 45 at the end there. So lots of stuff going on. Easy to tell. Let's see how we're doing here on this one. Now this one, only, 3 of them go down, one of them goes up. Well, there's the one going up. Darn it, I did it again. Let me get this, rid of these here. All right. Now this one is very steep, so that's the only possibility. That's got to be it. Notice that it has to go through negative 105. We could do the vertex and we could do some other stuff, but that's all we really need. Now these two both are the same shape because they both have a negative 1 as the leading coefficient. But notice that this one over here, the one over here goes through 0, 4, and the one over here goes through 0, negative 48. Hopefully you'll be able to tell which is which in just a second. There we go. This one goes through 0, 4, which is its y-intercept. So here it is. And this one, of course, is going to end up all the way down at 0, negative 48. Take a look. See, it's heading down that way. Anyway, there it is. Make sure I have it in there right. Yep. Okay. We're getting there. All right. Let's see. We've got 3 negatives and 1 positive. Clearly, the positive one is right here. And this negative one is at 0, negative 1, and it goes through 0, negative 2. So there's its graph right there. Now this one goes through 0, negative 81, and this one goes through 0, negative 45. But the one on the right is much, much steeper. The negative 3 is steeper, so it's got to be the one over here. And this one has to be that one over there. You see this one on the left is steeper. You can't see where I'm pointing, but this one is much steeper than this one. There's other ways to tell, but that'll be enough. This one looks like it's going to cross the y-axis before this one does, so there it is. See, they're going to really make us work for it, aren't they? All right, so now we've got, okay, they have the same shape. They're just in different locations. Notice that one of them is steeper than the others. This one has a y-intercept. Let me just point it out. This one has a y-intercept at 0, negative 6. Obviously, it is not that one. This one has a y-intercept at 0, 0. So this one is a possibility for right here. And it does go through 0 and 3, which is the correct one. Now this one over here has zeros at 6 and 8. And if you take 2 and divide it into all of these terms, one of the terms is going to be 48, which is 6 times 8. Chances are that's it. Now the other two, one is steeper than the other, and clearly this one is steeper than that one, I think. Let me take a look when I go down. Yep, this one is definitely steeper, and that one is not as steep. There's other ways to tell. It goes through 0, negative 6, and that one is going to end up at 0, 25, way up there. So ways to tell. Okay, let's see if we can match these up here. Okay, only one of them is going down. So let's put that one in there. This one is going through 6, 0, which is x minus 6 quantity squared. Now the other two, one of them goes through 0, 0. Let's see which one it is. There it is right there. So the one that goes through 0, 0 is on the left. That's this one. And this one is on the right. Let's see if there's another way to tell. Notice that the y-intercept is at 0, negative 6 for this one. That is the y-intercept, not the vertex. The vertex is really close to that. But also we can see that 2, 0 and negative 3, 0 are roots. So when we multiply those roots together, notice that we got negative 6 at the end. This one has roots of 0 and negative 5, and there they are. And the in between, the negative 2.5 is the vertex. Lots of stuff going on there, but that's how you can tell. I know it's easier if they're factored, but I can't see them all at the same time. So let's see. We've got a steep negative graph, which would be this one. We have a positive graph that has just been translated up 5 units. And then we have a negative and a positive at the end. So clearly there's my positive one, and that one must be my negative. Let's take a look. Yep, there they are. That's really all you need to be able to identify them. Let's see if we can do a little more identifying here. Let's see. Only one of them is negative. There it is. And this one was moved to the left. Both of these are moved to the left, but notice that this one has the perfect square. The perfect square is sitting on the x-axis. That's down here on the bottom right. And I'll show it in just a minute. This one is going through -7 and -8, and that is x plus 7 and x plus 8. And of course, this one is going to go through 0, 3. So a couple of things. Notice here's the vertex at 0, -2. This one has zeros at -7 and -8, and that would be x plus 7, x plus 8. Remember that your zeros and your factors have kind of an inverse operation going on there. In other words, in order to get the zeros for this, we have to put a -7 in and a -8. And these are the zeros or solutions to this equation. And that's why my roots are on the x-axis. This one down here is x plus 9 quantity squared. The -9 is what gives me my 0 and also gives me my vertex. And when -9 is substituted in for x, we do get a 0, and it's right there. That's my vertex at 0, -9, 0. This last one is x squared plus 3, and it's just been translated up 3. So there you go. I know a lot of stuff on those. I just wanted to make sure it's perfectly clear for the people that stick with me. All right. All of them are negative, so they're all going to go downhill, aren't they? But notice that one of them is on the y-axis. My vertex is on the y-axis. That is neither the case for either one of these. So f of x, the vertex has to be on the y-axis. G of x looks like a perfect square x plus 2 quantity squared with a negative in front of it. So that's this one right here. Let me just move him over here. Notice that zero, -2, 0 makes it a perfect square. If you take the negative out of this, you can see it's a perfect square. This one over here looks like a standard parabola, so it's not a -2, and it's not on the y-axis, so it has to be this one. And notice it does go through 0, -5. Now the last two, the steeper one is on the left, so it's got to be, this one has to go over here, and this one has to go over here. Let's move it up here a little bit. Now this one has a 0 at 6. That means that there must be an x minus 6 squared in this. And if you take the -2 out, you can see that that is the case. And this final one is on my y-axis, and it does go through 0, -5 is its vertex. There's a lot of stuff going on for these, and hopefully you'll practice them a little bit. They're so fun. I like matching these up. Okay, let's see. They're all negative. Put my eraser on so I don't mess it up. This h of x is going to be on the vertex. And here it is right here. Put him in. And this one over here has 3 and 6 as its two zeros. 3 and 6, it's probably this one. And let's see about the other two. One of them is steeper and one of them isn't as steep. This one is a bit steeper, and then this one isn't as steep. Let's make sure that those work out. Now this one has zeros at -3 and -8, which is true. And this one has zeros at -6. And notice, hopefully you can recognize it, that if you take the -2 out of this, you get x squared plus 12x plus 36. And it's all being multiplied by -2. Well, the -2 is what makes it really steep, and the x plus 6 squared part is what gives you your vertex at -6, 0. The -6 zeroes out my square. When you zero out the square, that's where your vertex is. So lots of stuff going on for those. Looks like we got 2 more to go. Man, they're really making me work. All right. I'm not even going to write anything. I'm just going to put them on here. All right, so this one is x minus 1 quantity squared. So my vertex is at 1, 0. This one has zeros at 7 and 3, which is this one right here. And then the other two, this one has to be on the y-axis, and this one is not. This one does have a vertex at 0, 4, and this one does have zeros of -2 and -7. And we have one last one. Let's see here. Okay, they're all negative. This one is on the y-axis. It's the y-axis is its axis of symmetry. Whenever there's no x value, that's the case because it's just getting moved up and down the y-axis. Now this one that has its vertex on the x-axis is a perfect square. And if you take the negatives out, actually you factor out the -2, and it looks like this one is the perfect square. You just have to take the -2 out to be able to see it. Now these last two, notice that the -6 should give us a huge hint because it has to go through 0, -6, and there's that point right there on the right. So 0, -6, and this one has to go through 0, -63, way down there. The other thing that gives us a clue here is that we have a 0 at -7 and -9, which means that we had to have multiplied x plus 7 times x plus 9 to get those two zeros. And then there was a -1 out in front of it. So that is that one on the left. So lots of stuff going on. Hope you'll practice. Hopefully get a little bit of insight today. And I will see you back again sometime. Get your mastery on that one. Bye-bye, everybody.